Okay, guys. Lesson 6. Fundamental theorem of calculus and definite integrals. And I don't remember if any other lessons were entitled Fundamental Theorem of Calculus, but we've already talked about one of the parts of Fundamental Theorem of Calculus a little bit, and we're going to talk about the other one as well today. So we're going to be working with both of them, but let's see. We've seen two major branches of calculus. Differential, so that's our derivatives, that's the tangent line problem, and now we're working with integrals and the area problem. Now, Leibniz and Newton are mentioned here, which officially, you've heard those names, both credited with discovering calculus. I think at the time it was more fighting over who discovered it, and now they're both, however many years later, they're both credited with finding it. We used this version right here of Fundamental Theorem of Calculus Part 1. There's a Part 1 and there's a Part 2. Part 2 is what we're going to learn today more. But we learned Part 1 a little bit and worked with it some. If f of x is continuous on the interval a to b, g of x is the integral from a to x of f of t dt. So this is when that top integral is a variable, what we are kind of doing there. Continuous on a to b. And it's differentiable on a to b, then the idea here that the derivative of g is equal to f evaluated x. So the idea that a derivative and an integral will cancel each other out, which I've talked about. Okay. Fundamental Theorem Part 1 says if we define a function as the definite integral of another function, the new function is an antiderivative. We're going to start looking at Part 2, which basically Part 2 is how do we compute a definite integral. In other words, when the numbers are boundaries, how do we compute that other than just plugging it in our calculator? Okay, because we can't rely, we're not going to always be allowed to do that. So, given that f represents the rate at which the function is changing, notice that function is the antiderivative, that f equals f prime, lower f equals capital F prime, we know that this integral represents total net change in f. Okay, so when we talk about area under a curve, that's the total change there. Now, let's see. If a function f is continuous on a closed interval a to b, f is an antiderivative of little f. Then, notice what it says here. The integral from a to b of f of x dx. How we're going to find that is we're going to find capital F, which is our antiderivative, and we're going to do the antiderivative evaluated at b minus the antiderivative evaluated at a. So basically antiderivative evaluated at the upper limit minus antiderivative evaluated at the lower limit. That is going to be the big thing today, is knowing how to do that. Okay. There's other notation here. And probably say you'd see the upper notation more. So in words, the definite integral of a function over the interval a to b is equal to the net change, or when we talk about this, we can talk about displacement. So you see that word displacement. Okay, another way, I'm too low there, I can't underline. But equal to net change or displacement in the antiderivative over the same interval, commonly known as the evaluation theorem. Now, I'll be honest, I can't say before this I've heard the words evaluation theorem. I must not have sat in the right calc workshop to hear that one, or heard the right thing, or maybe I have and I've just ignored it. But I like to throw the words out there, and in case you do hear them. Okay. Let's talk about how to use Fundamental Theorem of Calculus Part 2 here. So, when applying the fundamental theorem, we will follow this notation where basically what we're going to do is we're going to find the antiderivative, and we're going to use an evaluation line and put our limits there before plugging it in. Okay, so that's just kind of official notation. I'll use that as we go here. So, integral from 1 to 2 of x squared minus 3 dx, or in response to x here. Okay, don't worry about 1 to 2. Integrate. What is the antiderivative of x squared? Antiderivative of x squared?
1/3x cubed.
Okay. So whether you say 1/3x cubed or x cubed over 3, right? I've said both. I don't care what you guys do. 1/3x cubed minus, what's the integral of 3? 3x. No plus c. No plus c because we have limits. It's a definite integral. We have limits. We're going to plug them in. So now I'm going to say evaluated from 1 to 2. Now, the evaluation line like that, usually I use it more just that line when it's just one term. Because there's two terms here, what you will more commonly see are the box brackets here. Okay? Now, okay, we're going to plug this in. We're going to start by plugging in the upper limit. You're always doing upper minus lower. So I'm going to plug in the upper. So I'm going to say 1/3 times 2 cubed minus 3 times 2. That's my integral evaluated at the upper limit. And then it's always going to be subtracting. And now I'm going to plug in my lower limit. 1/3 times 1 cubed minus 3 times 1. This is definitely a non-calculator type question. I mean, obviously, you know, you guys throw something in the calculator or whatever, but this is something you need to be capable of doing without a calculator is what I'm saying here. Does that make sense? Because this is the type of integral you will see on the non-calculator portion that they're going to expect you to do by hand. It's easy once you know how to do it. Okay, so I personally am going to say what? I have 8/3 minus 6 in that first one. One-third minus 3 in that next one. I don't care how you do it from here. I mean, you can do each portion. You still kind of have to think about common denominator, don't you? Or you can just come up with common denominator and do all 4 fractions. So, let's see. If I say 8/3 minus 6, 6 is what in thirds? 6 is 18/3. So 8/3 minus 18/3 is going to be negative 10/3 minus 1/3 minus 3. Well, 3 in thirds is 9/3. 1/3 minus 9/3 is going to be negative 8/3, right? So now I have negative 10/3 minus negative 8/3. So negative 10/3 plus 8/3 is negative 2/3. Now, could you check this on your calculator? Yeah, on the AP you probably wouldn't have your calculator in front of you for this portion, but could you put this exactly into your calculator? We've learned how to do that, right? Math 9 is, you know, where I always think of it. But you can put that in your calculator, and that's a good check, right? Okay, gain some confidence. You probably won't feel like you really need to check, but it's not difficult math, just math. Okay, questions there? And obviously the calculator is going to give you the decimal, but you can always change it to fraction using the math menu, right? Okay. I should come up with questions. Let's talk B. Thoughts on B? Before we integrate this, we probably need to think of this as x to 1/2. Now, you can or you can't. Technically, that 3. You can technically, 3 is a constant, right? It's a constant multiplying it. You don't have to. But you can technically, pull that 3 out front and then just basically multiply your answer by it in the end is what I'm saying here. So if you want, you could say this is 3 times the integral from 1 to 4 of x to the 1/2 dx. And then what it is it's one less number to kind of mess with along the way. Okay? Do or don't, I don't care. Just giving you options. Okay. Integral of x to the 1/2 if we have that 3 out front. What are we doing? We're adding 1 to the power, which makes it x to the 3 over 2. When you divide by 3 over 2, you're going to be multiplying by 2/3. So it's 3 times 2/3 x to the 3/2 evaluated from 1 to 4. Now, if you want, that 2/3 is a coefficient as well. You could also pull that 2/3 out front if you wanted to. I'll be honest, I didn't think about it until I got down to the end. Okay, so I didn't. You can also work with the 2/3 as you go, right? It makes it a little bit messier. But if you want, you could think of this as 3 times the 2/3 out front, and then you're just evaluating x to the 3/2 from 1 to 4. That is equivalent, okay? So I do know 3 times 2/3 is actually just going to be 2. And I'm going to say, if you have it already, 4 to the 3/2 minus 1 to the 3/2. Now, make sure you know, can you do 4 to the 3/2 without grabbing your calculator? What do I mean, 4 to the 3/2? It's the what? Square root of 4 raised to the 3rd. Same thing over here. It'd be the square root of 1 raised to the 3rd. You know that. We went through that in Algebra 2. I'm teaching it right now in Algebra 2. So, I ran out of room. Square root of 4 is 2. 2 to the 3rd is 8. Square root of 2 is 1. 1 to the 3rd is 1. 1 to any power is 1. Yes? Okay. As I throw my... So we end up with a final answer of 14 eventually. Do we follow that one way or another? And if you left the 3 in there all along, if you left the 2/3 in there all along, it's fine. Okay? You'll do that sometimes. I do it all the time. So. Okay. Start thinking about what trick we have to use on C if you're already looking at C. I guess you wouldn't have to after some of the challenge problems we just talked about, but I'd still prefer it. We talked about this trick the other day, right? Yeah. Best thing to do is going to be to multiply this out. I'm not saying you'd have to. You could integrate it as is, you just have to watch out for a chain rule. But a better thing to do is going to be FOIL it out. So if I take 2x minus 1 times 2x minus 1, I'm going to end up with the integral from -1 to 1 of 4x squared minus 4x plus 1, assuming I did my math correctly. Are we okay with that? And now we're going to integrate. The integral of 4x squared. Add 1 to the power, divide by the new power. Minus the integral of 4x. Add 1 to the power, divide by the new power. Plus the integral of 1. All evaluated from -1 to 1. So 4/3 x cubed minus 2x squared plus x. Do we at least have these basics down? This is going to be old news. Okay, now, in this case, I have to integrate it as is. I don't, I can't pull this 4/3 out. It's not a multiple of everything. So we're going to have to work as it is, work with it as is. What am I plugging in first? Plugging in the 1. So if I plug in the 1, now I can go ahead and do this math as I go if I want to an extent. Like 4/3 times 1 cubed is going to be 4/3 minus 2 times 1 squared is going to be minus 2 plus 1. So there's me plugging in 1 minus, now I'm going to plug in -1. 4/3 times -1 cubed is going to be -4/3 minus 2 times -1 squared. It's still going to be minus 2. And now I have minus 1. And clean it up however you want there. For me, I think I said minus 2 plus 1 is minus 1. 4/3 minus 1 is going to be 4/3 minus 3/3 is going to be 1/3. Minus, I think my brain said minus 2 minus 1 is minus 3. Well, 3 in thirds is 9/3, so -4 minus 9/3 is -13/3. And then 1/3 minus -13/3 is going to be 14/3. You do you on the cleanup part, right? Questions on that one? Did you eventually match my answer? Okay. We're ready for D? Integral of sine x plus 1 from 0 to pi.
Does it go cosine, sine, or sine, cosine? I always like x and y.
Cosine sine, yeah.
Cosine, sine?
Yes. The ordered pair goes
Yeah.
cosine sine. Sorry, I was like, what are you talking about? Okay. Integral of sine of x. Well, I know it's cosine of x of some sort. Is it positive or negative cosine x? Negative, right? Because the derivative of cosine x is negative sine x. That wasn't negative, so I need a negative here. Plus the integral of 1 is x. Evaluated from 0 to pi. So, negative cosine of pi plus pi minus negative cosine of 0 plus 0. So, cosine of pi, my brain says, okay, what's the cosine of pi, which is -1. The negative of that is going to be +1, right? So I've got 1 plus pi minus Cosine of 0 is 1. The opposite of that is going to be negative 1. And then the plus 0. So I end up with 2 plus pi or pi plus 2, whatever makes you happy there. Okay. Are we having any thoughts on E? Move the x up. Okay. And there's a couple different ways we can look at this, but x, yes, definitely needs moved up. If I think about this, so give me a food for thought here. Did I use, yeah. It's square root of 2 divided by square root of x, yes? So if I move that up, which yes, you have to do, what if I say square root of 2 times x to the negative 1/2? As opposed to just saying 2 to the negative 1/2? Because what am I setting myself up, or 2 to the 1/2? Which is going to be a different power anyways. But what I'm setting myself up for is that square root of 2 can go out front. And you can just put it in front of your answer and not worry about it till you get to the end. Okay? So that would be my encouragement, is just think about the square root of 2 out there. So whatever I do, it's going to be square root of 2 times something, right? Integral of x to the negative 1/2. Add 1 to the power, divide by the new power. So I already have the square root of 2 out front, and then it's 2x to the 1/2. Now if you want, can you take that other 2 out front with it now? Yeah. You can put these 2 out front and just say, okay, I know I'm going to have 2 square root of 2. And then you're just plugging into x to the 1/2, which x to the 1/2 really means what? Square root. So we're saying square root of 8 minus square root of 1.
Why do we not just put it out front?
Because it's just a constant. I mean, you could leave it in there. But if you leave, I mean, by putting it out front, it's just going to still multiply into everything also, or it can, depending on how I rewrite it. Let's see. Square root of 8 is 2 square root of 2, if you will, minus the square root of 1 is 1. How did I leave my answer in the answer key? In the answer key, I have them multiplied together. So I distributed. And the big thing, the part that cleans up real nice, is that front piece. What is 2 square root of 2 times 2 square root of 2? Because you have outside 2 times outside 2, which is 4. And then square root of 2 times square root of 2 is another 2. So you're going to have 8, and then minus the 1 times 2 square root of 2. So 8 minus 2 square root of 2. Okay. I don't know that we'll get through this one all the way, but can you start it? Actually, can you work it? What's your starting step there? I wouldn't, well, I don't know. I guess it depends how you're moving the x up. And then what are you putting it as, like something to distribute into the x minus 2? Okay, so are we thinking about it as 2 separate terms here? I don't know. I'm not sure I don't know. Here's what my brain did. My brain's saying, okay, I'm going to clean up and think x over square root of x minus 2 over square root of x. So I kind of split it into 2 pieces. Is that what you guys? I don't know. Okay, I see some no's, I see some yeses. Not saying this would be the only way to do this. This is what I was doing. Because then I can say the integral from 1 to 4 of x to the 1/2 minus 2x to the negative 1/2. And that's what I'm going to be working with. I took that denominator, made the denominator in both pieces, and went from there. And I would say work on integrating this and doing it, and we can check it at the beginning of class tomorrow. Question or answer, Jacob?
I figured it out. Just to do the exponents, I figured it out.
Oh, okay. Oh, a question about the exponents. So, I'll give the final answer tomorrow. Unless you guys want to hear. There you go. We'll fill in the work tomorrow.